Hi, this is a video explaining an iOS application that I developed in Xcode using Swift language. It's basically a card game that my family and I have been playing since I was little, and I decided to make an application that resembles it. I go through a demonstration with the application on my phone in the first part of this video, and I go over a lot of the code in the rest of the video, so if you're more interested in that part, you can just skip to it. But yeah, I hope you find it interesting and maybe you'll see it on the App Store someday.
Right now I have it downloaded on my iPhone, so I'm going to go ahead and open it and just go through some of the game functionality. I go through the code right after this, so if you're more interested in that, you can go ahead and skip to it. So we can go through some of the rules. If you're curious on how the game works, you can pause it here and kind of read through them. We're going to go back for now and start a game. So you can enter your name here. I'm going to go ahead and enter my name. It's Cameron. And select the number of opponents. I only have functionality for 2 or 3 right now. We're going to keep with 2, and we're going to go ahead and hit start game. So the CPU is the dealer, and it will choose its deck autonomously. It does all these moves, and it has a form of simple AI that can pick the best possible move at any given scenario. So I can't stop on the first turn, so that's why this button is red. But I'm going to go ahead and pick a card here, and now the CPU will go again. So it's taken its card, and I've upgraded from 20 to 27 with that pick because they're suited. And actually the CPU got 31 off that, so they beat me. So it again shows how the simple AI is actually pretty smart. So I'm going to go ahead and hit the next round here. Now I'm the dealer. I can choose whether or not to keep or discard my hand. Right now I'm going to keep it. So their turn didn't really throw out much better. I'm actually going to swap all of these, so that's one of the possibilities of the game. I'm not seeing anything really better out there, so I'm going to go ahead and pass. And I get a little notification that I passed. They stopped. I'm also going to stop. And now I lost. So they beat me again. I'm down to 1 chip. And before I finish this game out, I'm actually going to exit it and just show you the functionality of the 3-person screen. So if I click on this, now we have 3 people in the game. So there's a CPU 1 and a CPU 2, and I can click through this. So now they'll go and it'll change to see who is up. And here with this move, they've actually thrown out a hand that I can get 31 with. So now it says I'm the winner and that CPU 1 lost. So if you look at their scores here, CPU 1 had 25, which you could add up, and CPU 2 had 26, so it barely lost. You can go ahead and hit next round. I'm the dealer. I'll keep that. And the round comes around to me again. So CPU 2 actually decided to pass there. So I'm going to go ahead and pick up this 9. I can't do any really better here, so I'm also going to stop. And so I've actually lost. So they have 3 kings, the CPU 2, so that's the equivalent of 30 and a half. And CPU 1 has 30, yet I only have 28. So I've lost. So you can see that my CPU simple AI is actually pretty smart. Also, if one of these players were to go down below 0 chips, they would be eliminated from the game, and then we'd go back down to that view with only 2 players in the game. Let's get into some of the code.
So initially in the beginning here, this is the main code. We are just initializing one of these game variables, and we are then going to the content view screen. So in the content view, this is basically the brains of the operation. It decides which views to show depending on what state of the game that the application is in. So we have a bunch of these state variables in the beginning that are being passed into each of these views down here.
In the beginning, all of them are set to false, so it'll default to this else statement, which will take you to the home screen, which is what it should do when the application opens up. So this is the home view. This is what you're seeing on the right now. And we're passing in the environment object that we created in the Shrimmin app, and that is just the game. Basically contains a lot of the functions that run the app. And then we have two Boolean variables being passed in, the settings and rules view. So the settings view will happen if you hit start game, and the rules view will happen when you hit the rules button. Then you can see some of the formatting. So we have the welcome to the Shrimmin app here, and the cards image, and two buttons here in a V stack, so they're vertically on top of each other. If you press this button, we will go to the settings view. If you press this one, we will go to the rules view. And basically some stuff happening here, some resets on the game that will happen when you want to play a new game. And background color, we have a green background color here. And this will be on every single one of the views. So let's see what happens when we hit the rules button. So we're going to go over to this screen, and basically this is just a bunch of rules that I typed out for the game. You can pause it here if you're curious how the game works. I'm just going to go through the functionality of it and not spend much time on the rules. So in this view, you can also hit the back button. So I gave this a scroll feature, so a scroll view you can see right here, and then we'll be able to scroll through the application itself. So we'll go back here, and now we'll hit the start game, and that will take us into the settings view. So this is the settings view, and we're passing in this environment object and the binding variables again. And so these are just some of the visuals that are set up. They can select a number of opponents, 2 or 3 with this wheel. We'll leave it at 2 for now. They can also enter their name. It'll default to player 1 if they don't select anything. They could hit the back button and it'll take you back to the home screen, but we'll not do that again. And the start game button is basically this entire function right here. So there are a lot of checks going on here. It basically has to do with the amount of players that are in the game, because as soon as they hit this button, the turns will start. And if the CPU is selected as the dealer, it'll have to perform certain functions. And if the user is selected as the dealer, then they'll also get a different screen. So that's basically taking all those into account. So we'll go ahead and get started. So I'm gonna hit the start game here, and this will take us to the choose hand view. So this is the choose hand view, and there will be different views depending on how many players are in the game and whether or not the user or CPU is the dealer. In this case, the user is the dealer, so they'll be able to choose between these two decks right here. And so I'll click one of these. It'll show me these cards, and then it'll give me an option on whether to keep them or discard them. And at all times, it will give us me the total, which is the amount of cards, the total among the cards, and how many chips they have left. So we're going to keep these, and it'll begin the game, and the CPU will take its turn. Okay, and now we'll go through some more of the settings that are in here. So that screen, as soon as that happened and the user selected a certain variable, which is this keep, it then goes to this moves view. And so this is the view we're in right now. There's 3 vertical, within the VStack, there's 3 items: the CPU's cards, the middle cards, and the player's cards. And there's also a bunch of these buttons here at the bottom. And the buttons do certain things depending on what state of the game that it's in. So whether or not they can pass, there's certain rules that govern this. Whether or not they can stop the game. Swap all is this button down here, or exit game will take them back to the home screen. So I'm going to perform a move right here just to kind of show you the buttons within here. So the middle cards class actually has buttons too. So we're going to go to that, and this basically gives us a title right here and 3 cards. So that's what you can see here. The title changes depending on which state of the game that it's in. This is for card 1, card 2, and card 3. So each of these cards is a button, so that when you select it, it will swap with the user if that is your decision for a turn. So we'll swap these cards right here, and the CPU will go, and take its turn. And actually, in this case, the CPU is the winner, and so you can see the next round has gone. They have a notification that they're the winner, so we're gonna hit next round. They're the dealer here, and I'll go through more of the views here. So in addition to the middle cards, we have these CPU cards, and this changes depending on how many CPUs are in the game. Um, if they're not the dealer or not, if they need to show their cards or not, this will all change. I have some scalars to change the sizes of the cards, but this is basically just a giant view that will change constantly, and if one of the players is eliminated. So this last view is the player's view, and the player's class is similar to the middle cards class, but it has much more. So name, the 3 cards, their score, the chips, whether or not they're the dealer, a bunch of other settings. And it also calculates this little, their score and the amount of chips that are left here. It will format this string right here. So the user's cards also act like buttons so that we can switch them out. But you can only switch them out with the middle card. So going like this had to be a possibility that had to be accounted for to make sure the user couldn't do that. And that only switches can happen when the user does something like this. So again, this is just all the different cards. It also has some states of the game to show whether or not they've passed, stopped, or if they're the winner. So if we pass, you can't pass twice in a row, so it'll turn red. That's one of the functionalities. So the dealer's cards is something that was in the choose hand screen. So if I stop this game and the CPU now shows its cards, you go to the next round, these 2 cards are basically the dealer's cards. There's also a winning screen, which will show at the end, possibly in the demonstration on my actual phone, because this may take a while. But it will basically show the places of each of the players that are in the game. First place gets a gold medal, second place gets a silver medal. But that'll be once the game is finished, when one person's chips have been exhausted. The deck is also, so this is how the cards are actually stored. So only 7s through aces are played. So we have to have a total cards deck, and then this new deck, basically every time a card is picked, so when they're dealt out, it will eliminate that from the deck so it can't be duplicated. And then we also have a function to reset the deck. But each one of these strings is stored within either the CPU, player, or middle card classes, and it is assigned to that class. So right now, this ace, queen, and 10, this would be a 14S, a 12S, and a 10D. So those are the cards that were within the total cards array. So finally, we're going to go to the game file, and this is the big file that has most of the functions and contains all the state variables of the game itself to make sure it is doing the right things at the right time. So I'm not going to go through all of these variables, but these are basically acting as flags to signal to the game, again, what part it is in. So they have to have players, they have to have the middle cards, there has to be a deck. It's basically bringing in all these files into one. Who's the winner, who's the loser, what the user's first and second selection was, what the CPU's first and second selection was, whether or not someone can stop. There's certain rules that govern that too that can be found in the Rules tab. So we have some functions to create the player, start the game. We'll basically reset all of these variables. We can reset the game, which will just reset the chips that are left. The label is this label right here. So we can format the score to look nicely like this. Some scores, like 3 aces or 3 8s, 9s, 3 10s, any 3 of a kind, will have to have a different score. And since I store this in an integer value, the decimals don't work. So I had to format it to a string decimal and calculate it to be a different number. This swap human function basically allows cards to be swapped like that. Swap CPU does the same thing, except it's the CPU's function, the CPU one again. So the CPU take turn, so this is another big function that basically allows them to take the best choice possible. This isn't the AI function, but calls the AI function, which is right here, and allows the CPU to make the best possible move. Depending on what move that they selected, they'll perform certain functions related to the game. So I'm just going to skip through a bunch of this code. That was a pretty large and difficult function to create. So we'll also take a look at the CPU AI function. So it's taking into account the middle cards and its own cards, and then it'll swap each of these. So pretending this is the CPU's cards, it'll swap each of these and store the highest score between them. So it'll also calculate the score of each of these moves. It can swap all, which I haven't shown yet, but it can do that. And it'll basically take that best possible move. If there isn't any good move, it can pass. If there isn't a good move and they already have a high enough score, they can stop. All these things are taken into account in this function. So yeah, this is assigning specific moves that the CPU take turn function uses. So at the end of every round, you also have to have a find loser function. So you have to find who has the lowest score and check how many people had that score, what the winner's score was. You need to check if their chip count falls below 0, then you need to eliminate them from the game, which is basically what this is doing. This will call the delete player function. The delete player function will remove them from the game, append them to a loser array, which is used in the winning screen, and we'll show who won the game. And down here, we'll format the chip similar to the format score. So the check winner function will check whether or not someone in the game has achieved a winning score. So that's either 3 aces or a 31, which is 2 face cards, or a 10 in a face card and an ace, all matched suits. So I go over that in the rules. And this is basically checking to see if one of the players has that. So the get score takes into account all other scores that aren't winning, and you're basically taking those cards array that are stored within the player and CPU and middle classes and converting these string arrays that are the strings that you see here for each of the cards and converting it into numbers and suits that we can work with. So right here for my hand, you can see this would be a 13D, 11C, and 12D. So after this formatting, the suit array will become DCD, and the number array will become 13, 11, and 12. It'll do some checks to see if the person scores a winning score. If not, it'll convert all these face card values to 10, which it is doing right here. None of these checks are going to go up until here. So the first and the last suits match. So suit 1 and suit 2, or the king and the queen match, but the jack and the queen do not match, which also means the king and the jack do not match. Then the total is going to be the addition of the first and the last. So 10 plus 10 is 20. And that's basically the main functions that went into building this application.
Thanks for watching my video explaining the iOS application I developed in Xcode, and maybe you'll see it on the App Store sometime soon.